today's content. So you'll notice that the little that one to record is showing up. I'm going to record this lecture. I'll strive to record all of the lectures from here on. I'll post them to the YouTube, and there will be a link on the webpage. I don't know how to video edit, so they'll just be what you see there and what you hear. So we made it last time to just thinking about this formal definition of the absolute value function. Let's just recall a few things. Let's hit, I think, these two items regarding absolute value. So here's this first one. Let's use the definition of absolute value, which is here to compute the quantity absolute value of pi minus 4. And I don't want a decimal approximation. So don't take out your calculator, that'll give you a decimal approximation. I want to know exactly what this is in a way that doesn't have any absolute value variability. So if you like, I'm asking you to take this quantity and plug that in for x in the absolute value function. So the absolute value function, it has different behavior depending on if the input is positive, negative, or 0. So let's try to answer that. Pi minus 4, is that positive or negative or 0? Negative, right? Because pi is somewhere around 3. If you're at 3 and you go left by 4, you'll be negative. So this quantity is negative. So if you look at the definition of absolute value, this case-wise definition, which of the 3 cases are you in? The bottom one? You're plugging in a negative thing. So the absolute value just says stick a negative sign in front of that number, and that's the absolute value. So this is equal to negative quantity pi minus 4. Everyone happy enough? Anyone think that should be simplified just a little bit? I guess you can distribute the negative sign, right? Okay, that's the same as 4 minus pi. Let's do one last one. The absolute value of x minus 7. I won't tell you what x is, but I will tell you that x is bigger than 7. So with just that information, what's the absolute value of x minus 7? And maybe I'll give you guys a few seconds to just ponder and talk with each other. Yeah. What I like to listen for is just enough conversation that I know that people are done. I think what is the absolute value of x minus 7 if you know that x is bigger than 7? It's positive, just x minus 7. Anyone want that talked through in any more detail than that? Nice. So I think there is one last thing that I actually want to hit in class. Let's think about solving inequalities that involve absolute value. And I think that we'll do two. We'll do this one and that one, even though that one I thought was supposed to be like a quiz today. I'm too slow. So maybe I'll ask a question like this at the beginning of class tomorrow. Still counts as a pop quiz because I didn't say it I definitely will. Let's try to solve the inequality. Absolute value of x is less than 3. And there's a general philosophy whenever you have an inequality that's even a little bit complicated, don't solve the inequality directly, solve equality. So let's solve the equality. Absolute value of y is equal to 3. What numbers are there that have absolute value equal to 3? Positive 3 and negative 3? So there are two solutions. And got space here, negative 3, 3. So those two places where equality happens are the places where inequality might change. So if we pick sample points between those two numbers and beyond, check if this inequality is true for those sample points, then we know everything. So let's try that. I don't know. Maybe I'll start with 1 to the left. What's a number that's less than negative 3? Negative 4. Plug y equals negative 4 into this inequality. Do you get a true statement or a false statement? So there's what you get. Absolute value of negative 4 is less than 3. What's the absolute value of negative 4? 4. Is 4 less than 3?
No.
No. So is that true or false? Okay. So that tells you something. That tells you none of these are in the solution set. Just by thinking about properties of absolute value, if I plugged in y equals positive 4, would something similar happen? Yeah. Well, absolute value forgets the negative side. That's the point of it. So none of these will be in solution set. So that leaves numbers between negative 3 and 3. Let's check one of them. What's the number between negative 3 and 3? 0. We could pick any one, but 0 is maybe the easiest number to use. What do you get when you plug in y equals 0? You get that it's true. You end up with 0 is less than 3. So those are in the solution set. So it looks like the solution is the interval from negative 3 to positive 3. But we need to decide whether to include or exclude endpoints. Should I include or exclude the endpoints? Exclude. Why?
Because it's not including anything after -3 and not including anything after 3.
Yeah. Well, what about exactly 3 or negative 3? I mean, I agree, they should be excluded. But you just need to check. If you plug in y equals 3, do you get a true statement? You'll get 3 is less than 3. So I think you had entirely the right idea. So let's just check one of those endpoints. Let's plug in y equals negative 3. You'll get absolute value of negative 3 is less than 3, but that is, of course, false. So that means negative 3 has to be excluded. Similarly, 3 should be excluded. How do people feel about that? That seem pretty okay? And I think let's do one last one. Let's do this one, and let's even do it on the back side. Absolute value of x minus 5 greater than or equal to 4. So there's an inequality to be solved. If you want to solve this inequality, what's a reasonable first thing to do? Solve an equality. And that'll separate the dealing with the algebra with the dealing with the inequality. So let's start by solving absolute value of x minus 5 equals 4. And so sometimes you want to undo everything on the left-hand side. So what should you do if you want to undo an absolute value? Yeah, like a plus or minus should show up. So if you know that x minus 5 is a thing whose absolute value is 4, then that thing, x minus 5, can be positive 4 or negative 4. Those are the only two things whose absolute value is 4. So x minus 5 is equal to 4, or x minus 5 equals negative 4. And maybe you would want to write that more quickly by just putting a plus or minus sign. This way I'll see the two different solutions totally written down. So what should you want to do to each of those if you want to solve those for x? Add 5 to both sides? So now I see two solutions, 1 and 9. So let's draw them out. There's 1, there's 9, and now we'll play the between and beyond game. maybe I'll check a number between, and then I'll split up the beyond into subsets of you guys. So what's the number between 1 and 9? 5. Okay, sure. So let's pick some sample points. X equals 5 to do the between case. What will you get for the original statement? You'll get 5 minus 5 is bigger than or equal to 4. Is that true or false? False, right? Because the thing on the left-hand side is 0. So that tells you that none of these numbers will solve the inequality. None of the numbers between. And here's what I'll have you guys do. To the left of 1, to the right of 9. Right, nutshot, when you have a lot of brains in the same room, you can do some of these things just in parallel. So let's see. Numbers to the left of 1, included or excluded? Included. To the right of 9?
Included.
Does anyone want me to talk through those in any more detail than just that? Okay. So all of these numbers are included. All of these numbers are included. So it looks like the solution set is negative infinity to 1 together with 9 to infinity. Infinities are never included. And now we have to decide whether or not to include those endpoints. How do you decide whether one should be included? See what happens when you plug it in? I guess, well, maybe I'll state a general rule of thumb after we do this once. So let's check 1. So x equals 1. Absolute value of 1 minus 5. What's the absolute value of 1 minus 5? Which makes sense, right? Because we got 1 by solving that equation. So we knew that would happen to begin with. Is 4 greater than or equal to 4?
Yeah.
Awesome. It should be included. In general, if you're solving something, this isn't a universal truth. If you're solving an inequality that involves less than or equal to, generally endpoints will be included, because you want to include solution points. Nice. Cool. So that means that the notes that I prepared for Monday were 20 minutes too long. With the remaining time, I'm sure that means that I will get through this set of notes, but let me give some more things. So let's start introducing some of the ideas of planar geometry. Right, so what we've done so far is we've established some of the translation between analysis and algebra and geometry that happens on the line. But it will turn out to be important to bump up that dimension by 1 and start thinking about geometry, analysis, and algebra on the plane. In particular, because one of the things we'll want to do is talk about graphs of functions. Ah, wonderful, thank you. And graphs of functions will live in the plane. Ooh, and let's do this. Evan Ash. Awesome. Haley Azuma. Jace Partis. Norma Bentley Thompson. Okay. Bug Blessar. Taylor Buell. No, Buell, Taylor Buell. But also not here. Okay. Trevor Clearman. Curly Conway. Monica Kokunato. Parker Eberhardt. Alex Engelsrud. Perfect. Laurel Freed. Anna Gartiek. Derek Hammer. Lauren Hautala. Max Hendricks. Ethan Herman. Perfect. Maddie Hohenstein. Mitchell Jorgensen. Trebek Lamond. Perfect. Courtney Lilly. Marius Loomis. Kenzie Lyle. Amy Madlin. Landon Massey. Delkin Matkovich. Danielle Middendorf. Jenna Miller. Anya Normando. Enoch Omweno. Amanda Wolf. Parker Russell. Sydney Schwantes.
Here.
Matthew Spy. Sophie Trok. Brian Van Beek. Perfect. Emma Vega Martinez. Anyone whose name did not appear? Okay, good. No late ads. So let's move on to planar geometry. And this will continue to be a fair amount of review. I just want to build up some of the language for thinking about points in the plane. So if you start to try to think about points on the line, if you want to find a number 5, start at 0 and go 5 to the right. To find points in the plane, we'll do the same. To describe the plane, I'll coordinatize it, Gesundheit, by drawing a number line. I'll locate its origin. I'll draw another number line perpendicular to that, so that they share an origin. So this is the point where those two origins meet. I'll describe it as the point 0, 0. Now, we need to talk about navigation. I want to associate to every pair of numbers a point on the plane. Somehow that makes sense. 2 numbers should give you a distance to travel in 2 different directions. And you already know what I'll do. If you want to find the point 5, 3, I'll start at the origin. I'll travel 5 to the right. 1, 2, 3, 4, 5. And then up by 3. 1, 2, 3. So there's the point 5, 3. Everyone happy enough? Similarly, you can find the point 3, 5 by instead traveling 3 to the right and then up by 5. If some of the numbers are negative, then you'll travel left instead of right or down instead of up, as you already know. If you want to find the point negative 4, 2, you'll go left by 4 and then up by 2. There's the point negative 4, 2. Everyone happy enough? Good. I'll describe the plane by breaking it up into quadrants. And I'll just do it counterclockwise. Top right is quadrant 1, and then counterclockwise quadrant 2, quadrant 3, quadrant 4. So notice quadrant 1s are coordinates which correspond to points specified by 2 positive numbers. Quadrant 2, well, it looks like those are numbers where I have to go left first. So those will be numbers where the first entry, the thing that will be called x, is negative. Quadrant 3, well, I go left and down. So x and y will both be negative. And maybe just to let everyone do a quick checksum, quadrant 4 should be specified by points x comma y where x is positive or negative? Positive, because it looks like to get to a point in that quadrant, I would start by going right. So x should be positive. Y, positive or negative?
Negative.
Negative, because you have to go down. Nice. So let's just go ahead and translate some of these into practice. So here are some points. Let's just go ahead and describe what quadrant they're in. 5, 3. Quadrant 1. And in fact, we see that. There's the point 5, 3. It's in the top right. 3, 5. Negative 4, 2. And that agrees because we found the point negative 4, 2 right there. The point 3 comma negative 2. Nice. And we can even locate it. 1, 2, 3, and then go down by 2. So all that works. Everyone happy enough? Happy enough is the wrong thing. Do people have any questions they want to ask right now? Good. So let's start doing some geometry in the plane. So the first thing that you might want to ask is, if you have 2 points in the plane, you can stick a ruler between them and measure the distance. How can you somehow get a formula for the distance between 2 points? That's what we'll do right now, because you're So we'll do it by just making an example. There's the point negative 1, 1. There's the point 2 comma 3. Are those points actually correctly addressed? Okay, good. I am unreliable. There will be many mistakes both in what I say and in the notes. You should always distrust everything that I do, especially if it comes down to, is this point actually in the right place? That's an easy mistake to make. I'll make them. So there are those 2 points. Let's try to determine the distance between those 2 points. So if I grab a straight line ruler and try to compute that distance, let's just try to see what it is. And here's how I'll try to compute the distance. I'll say, well, I can definitely, well, let's draw that triangle. I can definitely measure the length of the base of that triangle. How long is the base of that triangle? Let's see, that's the distance from this point to that point. So to go from here to there, it looks like I go right 1, 2, 3. So the length of the base is 3. Alternately, this point is 2, comma 1. The reason that that had length 3 is because the distance from 2 to negative 1 is 3. Similarly, what's the height of that triangle? 2. And again, you can see it by just looking at it. To go from here to there, it looks like we need to go up by 2. On the other hand, that's the absolute value of 3 minus 1, which is 2. Now, there's a rule that computes the length of the hypotenuse of a right triangle. And we'll come back to it geometrically in a bit. But for now, let's just write it down. If you have a right triangle with side lengths A and B, hypotenuse length C, then how can you compute the length of C? Yeah. The Pythagorean theorem says that c squared is the same thing as a squared plus b squared. Or if you really, really want to solve that for c, which we seem to, c is the square root of a squared plus b squared. Same statement as you guys just made. So I know what a is, it's 3. I know what b is, it's 2. So I should be able to find c, which is the distance between these 2 points. So the distance between these is the square root of 3 squared plus 2 squared. And I guess we should simplify that as much as we can. 3 squared is 9. 2 squared is 4. That's the square root of 13. There's an exact answer. Unless I've screwed up. Have I done anything bad yet? Okay. I was just getting a few looks like I'm crazy. I guess one thing that we might want to do is now approximate. What is the square root of 13 approximately? I guess what I'm really asking is how many people come to this class with like some sort of computing aid with frequency? Oh, okay. Well, I'm going to claim that you all really do, because how many people wind up carrying their cell phone with them everywhere they go? Yeah, so you can't use that on like an exam, but I want to take advantage of this moment, though, to do a quick demo of the computational tool that I'll use, though I don't want you to know my password. That I'll use with the most frequency throughout this class. That's Wolfram Alpha. How many people have used that before? Okay. I'll use it a lot. It's not the only tool to do things. Oh, in fact, maybe I think I won't, because I'll demo something else. How many people know about the Google calculator? Yeah, it turns out you can just type things into the Google search bar. That's not how you spell Google. Doing a Google search for Google, I know that's weird, but square root of 14. Approximately 3.6. So what is the distance from -1, 1 to 2, 3? The distance is the square root of 13, which is approximately 3.6. And maybe in order to emphasize this, because for the sake of things like exams it will be important, oftentimes in exams I'll ask for an exact answer. Which of those do you think I would think of as the exact answer? Square root of 13, because that is exactly what it is. 3.6 isn't exactly what it is, because as we saw, the actual answer is closer to 3.600555. So this answer, square root of 13, will be referred to as an exact answer because it is exact. Where 3.6 will be a decimal approximation. Generally, I'll be interested in decimal approximations if this problem is associated with an application I'd like to study, because then I'll care about the actual bigness of the number. If it's not associated to any particular application, then I'll be happier with an exact answer. Cool. Was there anything special about the coordinates in this triangle that made this argument work? You could have done this for any choice of points, right? If you do that, you'll find a distance formula. If you want to find the distance from a point with coordinates x1, x2, and a point with coordinates x2, y2, you can do so by taking the square root of the difference between the x's and adding to it the square of the distance between the y's. do that. Just, I think that I'll say let's do that for the point negative 3, 5 to the point 3, comma 2. And I'll give you guys two options. I can keep talking for a little bit, or I can give you guys a couple minutes and just have you guys do the computation on your own. Do you want me to keep talking through this? Okay, then I'll just be quiet for a little bit. As you come down to an answer, compare it with those around you. Oh, and I guess I'm also asking you for a decimal approximation, so I'll be able to tell people how an exact answer because I'll take that into account.
That's an exact answer. I added instead of subtracting. Mistake.
Cool. So what's the distance betwixt these points? Yeah. So it is approximately 6.7. But agree with everyone else's approximation? What is it exactly? Cool. So there's an exact answer. I would not refer to that as a maximally simplified exact answer. How would you want to simplify that? Yeah.
Like 3 times the square root of 6.
Almost. And I'll talk through it right now. 3 root 5.
Oh.
And let's talk about why that is. So let's take a moment and factorize 45. I'm not going to do this one, so I have this space to spare. What are the factors of 45? 9 and 5. It's 9 times 5. And as we'll see in a moment, square roots don't behave nicely over addition, but they do over multiplication. So I can rewrite that, and this is more walk than I would expect to see in an actual write-up, but this is why the simplification will walk. That's the same thing as the square root of 9 times the square root of 5. Square roots behave well under multiplication. But do you know a square root for 9? So if you want to maximally simplify an exact answer, which is often a good idea, you should look to see if the thing inside of the square root has any perfect squares as factors, because you'll be able to pull those out. Cool. So distance is 3 root 5, approximately 6.7. In order to highlight something to be aware of when you do walk with square roots, I'm going to talk through this computation, which will let us to compute the exact same thing, and arrives at a different answer. So apparently one of those steps is wrong. Let's talk through it and see where something wrong happens. So the distance is given by the square root of -3 minus 3 plus the square of 5 minus 2. Is that correct? Yeah. There's the difference between the x's squared plus the difference between the y's squared. Apparently that simplifies to negative 6 squared plus 3 squared. So far, so good. Cool. 6 squared is 36, 3 squared is 9. That's the same thing as the square root of 36 plus the square root of 9. Ah, lots of head shaking. That's not true, is it? Square roots don't distribute over addition. So, but that seems like an easy mistake to make if you're going through a problem and you're only half aware of what's going on. So, when you're doing walk, especially on things like exams, because those are high stress situations, be aware of that mistake, because if I see that mistake on something like an exam, it'll also make me really, really mad. So that's a caution to be aware of. So there's talking about measuring distance between numbers. Let's think about averages between numbers, or midpoints. So if I give you two numbers, two just numbers on the line, you can find the midpoint between them by just taking their average, adding them up, dividing by 2. And in order to see if that actually does what it seems like it geometrically should, was it a question? No, okay. Let's try to formally compute it. So let's see what happens. What's the midpoint between 4 and 10 according to this? Yeah, 7. Nice. Add them up, you get 14, divide by 2, get 7. If we draw these things on a number line, there's 4. There's 10. 7 certainly is between them. And yeah, that looks like it's exactly the same distance from 7 to 4 as it is from 7 to 10. So yeah, that is honestly the midpoint. The formula does what the geometry thinks it should. We can do similar things for points in the plane. If I draw a line in the plane, a line segment from this point to that point, I should be able to find the exact middle of that line. Or at least I would be able to if I were capable of drawing a straight line. That's obviously not straight, but you'll just have to forgive that. It'll be even worse once I get to like having to draw circles. They'll look real bad. If you want to find the midpoint between 2 points in the plane, you do something really similar to in the line. You take the midpoint between their x values, and you take the midpoint between their y values. And again, let's just see that this actually does what it seems like it should. Let's find the midpoint between negative 1, 3 and negative 3, 1. And so we know what we need to do. We take the midpoint between the x values, so that's negative 1 plus negative 3 all over 2, comma, 3 plus 1 all over 2. Good enough? What did that simplify down to? Negative 2, 2. All right, the arithmetic is easy. Doing the arithmetic wasn't the point. The reason I asked you guys to do it and didn't do it myself is because I probably would have screwed it up. So let's draw these points and see if it actually seems right. So negative 1, 3 is negative 1, 1, 2, 3. Negative 3, 1 is 1, 2, 3, 1. Draw the straight line between them. And apparently I want the point negative 2, comma 2. Negative 2, 2. Does that look like it's about the exact midpoint of the line? And maybe it even seems believable that this should always do that. Nice. So with 5 minutes remaining, I want to start in on Gesundheit.
Thank you.
What is the main reason that I want to start walking in the plane whatsoever? And that's in order to think about graphs of equations and eventually graphs of functions. So here's an equation. I'll give a definition that's a definition in an example, but here it is. If I give you an equation, then its graph is all points x comma y. Right. Points are a pair of number on x value and a y value, satisfying this equation, 2x minus y equals 6. Good enough, and also presumably pretty familiar. So one thing that we can do with graphs is we can definitely check if a point is on a graph. So we just need to see if this equation is satisfied. So let's perform some of those checks. Let's decide if 2 comma 6 is on that graph. So that means I need to check if that x value paired with that y value satisfies the equation 2x minus y is equal to 6. Maybe I'll do this in more work than one often would. So that means I need to compute 2x minus y and see what I get. So I'll get 2 times 2 minus 6. And now that I have that all written down, I guess that's negative 2. Did that give me a result of 6? So this point is not on the graph. And I think I'll go ahead and check one more. If time weren't a constraint, then I would have you guys do more, but I think that I'll just do the one. Let's see if the point 6 comma 6 is on the graph. So that means I want to plug in x equals 6, y equals 6. 2x minus y will become 2 times 6 for this 6, minus y, which is 6. That is 6. So is that point on the graph? So that's nice. Once you have an equation, you can check if any point is on it. What's more interesting is if I give you an equation, and you can find all of the points on the graph, then you can read off lots of information just by looking at that graph. And that's where we'll start. Well, no. Yeah, this is so awkward. Because this takes, yeah, that's good enough. We'll stop. Cool. So, the homework posted for this note, this set of notes is on the webpage. Again, we didn't cover all the contents, so some of the homework will really be homework that should be assigned tomorrow, but because that doesn't affect deadlines, I won't do anything about that. If we make it to Friday and don't make it to all the notes on Friday, then I'll reassess the homework assignment. What do I press?